Yes, good afternoon. My name is Minsal Kibalan, and these are just Convos. We've already started our conversation of artificial intelligence, and I figured we would just go ahead and continue that. We have mentioned in some of our previous conversations that artificial intelligence is mathematics. That's what it is. It's not magical mumbo jumbo. It is mathematics, and this is just one example of that. These are measures of similarity that we will talk about today. And we're talking about similarity because similarity is a big part of artificial intelligence and machine learning. It's a very, very big part of it. The way the system processes data and ultimately the results that are derived from that data are a big, are largely determined by what the system, how the system defines how to, whether two things, how similar two things are, right? So we'll just go through these three, and I'll try to give you a use case for each one. First, we have the Euclidean distance. This one, don't get spooked out by it. This is a summation symbol. This is your square root. You know what that is. We're squaring here. But essentially what you have, for those folks who are familiar with the Pythagorean theorem, this is simply a generalized form of that. So if you just had two dimensions, which is what you probably worked on in middle school with the Pythagorean theorem, and expanded this out, then it would look exactly like the Pythagorean theorem. But like I said, this is a generalized representation of this. A use case for this would be clustering algorithms like k-means, where you have different points and the vectors are of different lengths, etc. So that's where this would come up. And here what you have is cosine similarity. So A is a vector, B is a vector, and here are vectors here as well. We're trying to find the norm of those vectors. So the dot product is, I guess this is moving ahead to, you might have had this in maybe pre-calculus trigonometry, where the dot product is you're taking an angle between two vectors and finding the cosine of that angle. And if you remember how the cosine works, is that the closer these angles are together, the larger the cosine becomes. So that's how you can intuitively think of the way this similarity measure works. The closer these angles come together, the more similar it is. And obviously, the further apart, the closer this gets to a 90-degree angle, the weaker the similarity becomes. So that's just one way of measuring similarity. And use case for that would be text of text analysis. That'll be one use case of that. And we'll be able to go deeper into some of these things at a later time. But I just wanted you all to have a foundation. Last but definitely not least is the Jaccard similarity. This one is fairly common. You may not have heard of it, but you will if your study of artificial intelligence, if you continue it. You'll see here, these are typology symbols, set theory, etc. So here we have an intersection at the top here. This symbol is the union. So you basically have the ratio of the size of the intersection over the size of the union. Use case here would be something like recommendation systems. So again, I can't go too deep into these things today. But here you get Euclidean distance, cosine similarity, Jaccard similarity, measures of similarity. Measures of similarity are very important in the study of artificial intelligence and machine learning. And I hope we'll get a chance to go more in depth with each one. But I think that this is a good place to stop. We'll talk later. Peace.